Hi everyone. Is the audio video volume is everything fine? Please tell me. Is everything good? So let's start now. So this is our standard question session for digital logic, and this is the session number 3. In the last two sessions we have done many standard questions we have solved, okay, for Boolean algebra. Like the session 2 you can watch. In the session 2 we have done the Cambridge University questions, okay, the past exam questions of the Cambridge University. Those questions we have solved in the session number 2. In the session number 1 we have solved some questions on counting special type of functions, okay. Also we have done some questions from the Charles Roth book, okay, so you can check it out, session number 1, session number 2. Now this is session number 3. In this session we will see some questions, some tricky questions related to K-map. Also we will see what is dummy Boolean variable. This analysis we will do. Remember, this is the analysis. This is not a standard terminology. Okay, this is analysis. So this analysis we will do. Some tricky questions of K-map we will do, and some questions related to decoder and multiplexer we will do in this session. Okay, now let's start this session. So let's start now. So you can notice that if you go to this link, then you will find uh, this Cambridge University past exam papers you will find for digital electronics, okay, and all the gate relevant questions I am taking and we are solving. You don't have to visit this link. You don't have to solve those questions, because all the gate relevant questions I will take in these standard sessions, and all the questions we will solve. Okay, so there are many questions here, and all the gate relevant, each and every gate relevant question we will solve in these standard sessions. Okay, so this is standard session 3, and there will be in the future also there will be standard sessions, okay, for digital logic. For every subject there will be standard question sessions. Now let's start with the first topic, that is dummy variable, useless variable. See, this is not a topic, this is a question, this is an analysis. Okay, because in the gate exam, see, this is not a standard terminology. Like in the books, in the standard books, you will not find this terminology. Okay, so this is not standard. But in the gate exam they will not use this word. Okay, they will not give you this word. What they will give you, they will give you the definition of this word. Okay, they will give you the definition, they will define this, and then they will ask you some questions. So basically this is an analysis type of thing. Okay, you have to analyze this. Now let me explain what is a dummy variable, or you can call it useless variable. Okay, the name itself is telling you that it is dummy. Okay, it is a dummy. So let's start with this. What is a dummy Boolean variable? So consider this function. Just consider this function f a comma b equal to a bar. Tell me, this is a function on how many variables? Look at this function. This is a function on how many variables? This is a function on two variables, correct? There are two variables a comma b in this function. But can you notice that in this function I can say that b is useless? Can you notice that b is basically useless for this function? For this function this b is useless, or you can call it dummy. So this b is just, I can say this b is just for show off. Okay, this b is not doing anything. Okay, so this is just useless, or I can say dummy. This is not doing anything. So I can say this is a function on two variables, but this b is dummy. So remember, this is a function on two variables. Here I can say this is a function on two variables. There are two variables in this function. Okay, those two variables are a comma b, but this b is useless or dummy. So if you make the truth table, see what will happen. If you see the truth table of this function, then it will be like this. Look at this. Okay, so actually what is happening, actually this is happening. See, this function, this function, this only depends on a. Okay, so if a is 0, then function will be 1. If a is 1, then function will be 0. This is what actually happening. Okay, this is what actually happening. Now you can notice this f is only depending on a. So if a is 0, then f will be 1. If a is 1, then f will be 0. So f is equal to a bar. Now for this function, if you create the truth table for this function, then what you will get, you will get a b, and there will be f. Okay, and there will be f a comma b. Remember, this is a function on two variables a comma b, and this function is a bar. So you can notice that this function depends only on variable a. Okay, so you can notice this function will only depend on variable a. If variable a is 0, then function will be 1. If variable a is 1, then the function will be 0. Now notice that this will not depend on b, so it does not matter what is the value of b. It does not matter what is the value of b. It does not matter. Okay, as long as a is 0, the function will be 1. As long as a is 1, the function will be 0. Okay, so it does not, basically this is dummy. Can you notice this line? Can you notice this is just a dummy? I can say this is a dummy variable. Okay, this is just a dummy variable, because it does not matter what is the value of b. It does not matter for this function. It does not matter what is the value of b. B is 1 or b is 0, it does not matter for the function. Okay, the function does not depend on this b, so this b is just a dummy variable, or I can say useless variable. Okay, let's see another example. So okay, actually now notice this example. Actually, what is a dummy variable? Look at a dummy variable. Okay, so if you notice a dummy variable, then what is happening here? In the dummy variable, what happens? In the dummy variable, this happens. See, okay, let us assume there are two variables. Okay, let us assume there are two variables. Assume that b is dummy. Then what will happen? Okay, just assume b is dummy. Assume b is a dummy. Assume b is dummy. Then actually what will happen? Okay, if b is dummy, then what will happen? See, in this situation, what will happen? Because b is dummy, it means the function does not depend on b. It does not depend on b. B is dummy, so the function does not depend on b, so the function only depends on a. Now notice, okay, tell me, if b is dummy, if b is dummy, will these two values will be different or same? These two values will be different or same? These two values, they will be different or same, because b is dummy, so function does not depend on b. Okay, function does not depend on b, so that is the reason I can say these two values cannot be different. These two values will be same. Okay, these two values will be same because b is dummy. It does not matter what is the value of b. Okay, remember, value of b does not matter. B is dummy, it means b is useless. It means changes in b does not matter. Okay, it means changes in b does not, okay, change f. I can say what this means. This means change in b, change in b does not affect, does not affect f. Can I say this? Change in b does not affect f. Now you can notice that here also, here also, here also, a is 1, and okay, it does not matter what is b. Again, these two will be same. These two will be same. Okay, so this type of function, this type, in for this type of function, I can say b is dummy. I can say this b is useless, or I can say b is dummy. Okay, so this is the idea of dummy variable. What is the dummy variable? I can say change in b does not affect f. Okay, so this is the idea. Now tell me how many functions are there where b is dummy? How many functions you can create where b is dummy? Number of functions where b is dummy. So what you can do? Number of functions where b is dummy. So this is your f a comma b. So tell me how many functions where b is dummy? How many functions? How many functions in which b is dummy? In which b is dummy? B is useless. Okay, b is dummy. B is useless. So how many functions? Very simple. Because if b is dummy, then you already know that these two values will be same. These two values will be same. Okay, so there are two choices here. There are two choices here. So answer will be 4. Okay, the answer will be 4 because b is dummy. Okay, remember, b is dummy, so the answer will be 4. It simply means that it does not matter what is b. It simply means that it does not matter what is b. Okay, this is, I can say that it will only depend on, it will, the answer, it will only depend on a. Okay, so it does not matter what is b. I can say these two must be same, and I can say these two must be same. Okay, so finally I can say these two must be same, so there are two choices. There are two choices, and these two must be same, so there are two choices. So finally number of functions will be 2 into 2, that is, okay, so that is 4. So there are 4 functions in which b is dummy. Okay, there are total 4 functions in which b is dummy. What are those 4 functions where b is dummy? Let us check it out. Okay, so where b is dummy, if b is dummy, then what are those 4 functions? Those 4 functions, what are those if b is dummy? Okay, so if b is dummy, then I can say that you can notice 0 0 0 1 1 0 1 1. Okay, so it will only depend on a. Basically forget about b. Okay, just forget about b. okay, I can say these two must be same, these two must be same. So this can happen. So this can happen, correct? This can happen. These two must be same, these two must be same. So I can say that this also can happen. These two must be same and these two must be same. So I can say this also can happen. And I can say these two must be same, these two must be same. So this also can happen. So there are total four functions. Total there are four functions, and you can notice these are the functions. Can you notice what is the equation of f1? Tell me what is f1? You can notice in all these functions b is dummy. In all these functions this b is dummy. This b is dummy in all these functions. Okay, so what is f2? F2 is a bar. What is f3? F3 is a. And what is f4? F4 is 1. Can you notice in all these functions b is dummy? Is this clear to everyone? What is a dummy variable? Okay, so you can think, remember, dummy variable is like non-existing. Okay, dummy variable is, I can say for function f, this dummy variable is like non-existing. For f, this dummy variable does not exist for f. Okay, think like this. You can think like this, that this does not exist. For the function f, this does not exist. Function f does not care about b. Okay, so okay, function f that does not care about b. So finally I can say that there is only a. Now how many functions are there? There will be only one variable. From f point of view, for function f point of view, there is only one variable. Okay, basically this is like non-existing. I can say this is like non-existing for f. Okay, you can think like this. This is non-existing for f. So for f there is only one variable, and on this one variable only four functions you can create. Okay, only four functions you can create on this one variable. So like this. Okay, is it clear? Is this clear to everyone? So you can notice that for this function f, for function f, I can say for function f, this b, this is like non-existing. It does not exist for function f. Remember one more thing. If you notice in this f1 and f4, a is also dummy. In this f1, f4, okay, look at f1, f4, you can notice that a is also dummy. Okay, so this point you can notice in f1, f4, in f1, f4, a is also dummy. A is also dummy in f1, f4. So this is what I'm saying, that if both are dummy, assume a comma b both are dummy, then how many functions are possible? It simply means, okay, both are dummy means function does not depend on a comma b. Function does not care about a comma b. Okay, so if both are dummy, both are useless, then there is only one function you can create. Okay, you can create only constant function you can create. Because remember, these are dummy, it means changes happening in them, it does not change the function. So only two functions will be there if both are dummy. So if all the variables are dummy, then I can say that only two functions you can create. One function is function 0 and another function is function constant. Only constant functions you can create if all the variables are dummy. Okay, now let's see the definition of dummy variable. See, remember in the GATE exam, this dummy variable, this word will not be given to you. This word is not, okay, in the GATE exam, this is not a standard word, dummy variable. Okay, this is a non-standard, I can say. This is not a standard terminology. This is not a standard terminology. So in the GATE exam, they will not give you this word. This word will not be given, but the definition can be given. Okay, in the GATE exam, they can give you the definition. Okay, they can give. So let's find out the definition of this. What is the definition of this dummy variable? Okay, so what is the definition? The definition is very simple. And what is the definition? That changes in dummy variable does not change the function value. Okay, I can say that changes in dummy variable. If you change the dummy variable from 0 to 1 or 1 to 0, okay, changes in dummy variable does not change. Okay, does not change function value. Does not affect or does not change function value. Change the function value. Okay, so this is the definition of dummy variable. Means, okay, means if you change the dummy variable, then it simply means that it does not affect change, it does not change the function value. This is the definition of dummy variable. Okay, in this function cs, in this function, can you notice in this function, which for this function, look at this function, f a comma b equal to 0. This function is always 0, right? Look at this function. This function is always 0. This is a constant function. This is your constant function. This function is always 0. Okay, so it does not matter what is your A, what is your B. Can you notice? For this function, for this function, for this function, I can say A comma B both are useless. Both are useless for this function. Whatever value of A you take, whatever value of B you take, it does not matter for this function. For this function, the value of A comma B does not matter. For this function, the value of A comma B, the value of A comma B does not matter. This function is always 0. This function is constant function. So both A comma B are useless for this function. Is this clear? So if all the variables are dummy, okay, so it simply means that only two functions you can create, constant functions. Okay, function 0, function 1. Only these two functions you can create if all the variables are dummy. You can notice in this function A comma B are useless. This function does not depend on A comma B. Okay, so this is the definition of dummy variable. Dummy variable means change in dummy variable does not change the function value, or I can say that function does not depend on it, or I can say function does not depend on the dummy variable. I can say function value, function, or I can say function value. Okay, function, or I can say function value does not depend on dummy variable. Does not depend on dummy variable. This is the definition of dummy variable, that function does not depend on the dummy variable. It does not depend on the dummy variable. Is it clear to everyone? Tell me. So this is the definition. Look at the definition. So how will you define for two? Okay, for f a comma b, how will you define that b is dummy? Okay, you have, okay, then b is dummy if and only if. How will you define this? B is dummy if and only if. How will you define this? B is dummy if and only if. Remember, if you change B, like, okay, then function value will be same. If you change B, then the function value will be same. Is this clear to everyone? Please tell me. B is dummy. B is dummy means, okay, B, this B is dummy. Dummy means useless. Dummy means useless. B is dummy if and only if you change B, okay, keeping the A same, keep the A same. If you change only B, if you change only B, you can notice if you are changing B, if you are changing B, okay, if you are changing B, then you can notice function value is not changing. Okay, so this, in this type of, okay, this is the definition of dummy variable. Is this clear to everyone? So B is dummy if and only if f a comma b is equal to f a comma b bar. This type of function, okay, this type of, I can say in this type of function B is dummy. In this type of function I can say B is a dummy, because when B is changing, then this a, f is not changing. F does not care about B. Now let's see this one, f a comma b comma c. In this, what you will say? How will you say that f a b is dummy? How will you say, okay, there are three variables. How will you say that B is dummy? Very simple, that if you change the dummy variable, if you, okay, keep the other variable same, if you change the dummy variable, then function value does not change. FABC is same as FAB bar C. Okay, in this situation, we will say that B is a dummy variable. This type of variable is called dummy variable. Is this point clear to everyone? Okay, so very simple point. So the same thing you can say for n variable. If you have total n variable, okay, let's assume total n variables. You have a1, a2, and so on an. This is your n variable function. Then in this situation, ai is a dummy. When can you say that ai is dummy? Ai is dummy if and only if, okay, ai is dummy is if and only if you change ai. Okay, remember, if you change ai, so here you have ai minus 1, and here you have ai. Okay, if you change ai, if you change ai, okay, and other things are same, okay, keep other things same, so just change ai. So for example, I am changing this ai, and the other things I am keeping them same, ai plus 1 and so on an. So this should be same as, this should be equal to, this should be equal to f. Okay, I can say that this should be equal to f. If you change the dummy variable, okay, a1 and so on ai minus 1, if you change the dummy variable, means if you change this dummy variable, okay, then it does not change the function. It does not change the function. Okay, in this situation, we will say that ai is a dummy variable. Okay, remember another definition. Basically I am saying that, basically I am saying that If a is if this is 0 or this is 1, it does not matter. Is this clear? It is 0 or it is 1, it does not matter. Like you can notice this b is dummy. See, this b is dummy. I can say that whether this b is 0 or whether this b is 1, it does not matter. Whether this b is 0 or whether this b 1, it does not matter. Okay, similarly here I can say that whether this b is 0 or whether this b is 1, it does not matter. It does not matter whether this is 0 or this is 1. So this is what I'm saying, that dummy variable is 0 or dummy variable is 1, it does not change the function. Is this clear? Anyone has any doubt in this? Yes. Yes. So basically, if remember, if f a comma b comma c, okay, if some function is given to you and let's assume b is dummy, okay, some function is given to you and assume b is dummy, okay, b is dummy, then I can say that this f, okay, does not depend on b. This f does not depend on b. This f does not depend on b. So okay, so we can think of, okay, so we can think of f as f a comma c. Okay, so like this. Is this point clear to everyone? So if b is dummy, okay, if b is dummy, then f does not depend on b. F will not depend on b. Okay, f does not depend on b. So we can think of as f as f a comma c. Like this you can think. But remember, okay, your function has three variables. Remember, number of variables is not changing. Number of variables is same. Number of variables is same, but you can think of f as a comma c. Like this you can think. Okay, so very simple. So can you notice, tell me, is it possible dummy variable can appear in the expression? This is my question. Can dummy variable appear in the expression? This is my question. Let's assume f a comma b, let's assume this is the function and let's assume b is dummy. Let's assume b is dummy. Then can b appear in SOP? Can b appear in SOP of f? Can b appear in SOP of f? Or I can say, can b appear in expression of f? Can it appear in expression of f? Tell me. This is the question. Can it appear in the expression of f? If okay, b is dummy, then can b appear in the expression of f? And the answer is yes, it can. Okay, yes, it can appear. Okay, remember, yes, it can appear. For example, you can notice that this function b is dummy. Look at this function. In this function b is dummy, but this function I can write like this. This same function I can write like this. So b can appear, right? Okay, this same function you can write like this. Okay, the same function you can write like this. So can b appear in the expression of f? Yes, it can appear. Yes or no? So this is my question. Can b appear in the expression of f? Answer is yes, it can appear. Yes, it can appear. Now another question. Can it appear in the minimized expression? Can it okay, can it appear in the minimized expression, minimum expression? Can it appear in the minimum expression? Now the answer will be no. Okay, now the answer will be no, because function f does not depend on b. Okay, so this b is dummy. I can say this is useless for function b. So now the answer will be no. So dummy variable does not appear in the function, in the minimum expression. In the minimum expression, it does not appear. But remember, of course, you can do like this. Okay, this type of thing you can do. This is same as a. This is same as a. So this type of thing you can do. But finally, I can say that in the minimum expression, this does not appear. Whatever you take. Okay, so this is the final conclusion. Dummy variable does not appear in the minimum expression. In any minimum expression, whatever minimum expression you take, dummy variable does not appear. Remember, dummy variable are like non-existing variable from the function point of view. Okay, from the function point of view, these are non-existing variable. Okay. Now, also remember that this is not a standard terminology. In the GATE exam, they will not give you this word dummy variable, but they will give you the definition. They can give you the definition of it, and you have to find out. You have to analyze this definition, and you have to check. For example, in the GATE exam, if this definition is given to you, what you will say? In the GATE exam, this definition will be given to you. See this definition. F is a Boolean function on n variables. These are the n variables. This is a dummy. This is dummy if and only if you can notice. If you change this, then function value does not change. Okay, dummy variable. If you change the dummy variable, then the function value does not change. Okay, in this situation, we will say that this xi is a dummy variable. So this definition will be given to you. I hope this point is clear. So let's solve this question. Tell me the answer for this. Like before we solve this question, let me ask you some easy ones. Okay, where I can ask you where g is a dummy variable. Where g is dummy variable. So tell me the answer now. Where g is dummy variable. This g is dummy variable. So now what is the answer? How many functions are there where g is dummy variable? How many Boolean functions you can create? How many Boolean functions you can create where g is dummy variable? So the answer will be, remember, because g is dummy variable, so you can just forget about it. Okay, remember, g is dummy variable, so you can forget about it. You can forget about it, and then finally you can say that basically how many functions are there on these variables. On these variables, how many functions are there? So you can forget about the dummy variable. Okay, so the number of functions on 6 variables, okay, that will be 2 power 6. Okay, so the answer will be 2 power 6. Is it clear to everyone? Okay, so remember, in the GATE exam they will not give you this dummy variable. This word will not be given to you. Again I am saying, this is not a standard terminology. In the standard books you will not find this, but in the GATE exam they will give you the definition. Okay, this definition they will give you. Okay, and then they will ask you, after giving this definition, they will ask you this question. This question they will ask you. Okay, very simple. So because g is dummy variable, so you can forget about it. Okay, you can just forget about it. Okay, so just forget about g, I can say. Okay, so f, just forget about g, I can say. Just forget about g, you can forget about g. Next, so tell me the answer for this question. These variables are dummy. In this question, e, f, g, these three variables are dummy variables. These three variables are dummy. So now what will be the answer? Very simple. Now you forget about them. Okay, so for function these do not matter. I can say for function these do not matter. Okay, for function these are like non-existing. These are like non-existing. For function these are like, I can say, these are like non-existing. Okay, so you can forget about them, and then finally you can find how many functions are there on the remaining variables. Okay, so the answer will be what? Okay, so the number of function that will be 2 power 4. Okay, so the answer will be 2 power 4. Also remember one more thing. This important thing I want to tell you, that also remember that, okay, I am not saying, see, does it mean that ABCD are not dummy? Does it mean ABCD are not dummy? Tell me, does it mean ABCD are not dummy? No, it does not mean. It does not mean. It simply means that these are dummy. The remaining variable may or may not be dummy. Okay, it simply means that these variables are dummy, the remaining may or may not be dummy. For example, let's take this question. Consider this question where B is dummy. Okay, where B is a dummy. Like, okay, function on two variables, A comma B, where B is a dummy variable. Now what will be the answer? Where dummy is this B is the dummy variable. Now here what will be the answer? Tell me. Here the answer will be very simple. Okay, just think about f(a). Okay, so number of function will be 2 power 1, and that will be 4. But remember, in these four functions, a may or may not be dummy. Remember, in these functions, a may or may not be dummy. A may or may not be dummy, but definitely B is dummy. A may or may not be dummy. Okay, remember, A may or may not be dummy, but B is definitely dummy. So this is given to you that B is dummy. Okay, is this clear? Is this question clear? Like, if the question will ask you that A should not be dummy, if I ask you this question, A should not be dummy, then what you will do? Okay, if this question is asking that B is dummy, but A should not be dummy, A should not be dummy, then what you will do? A should not be dummy. Then what are you going to do? So very simple. You find where B is dummy and then you remove where A is dummy. So the method is very simple. What you will do? Okay. So basically it is saying that B is dummy. Okay. This is like a inclusion exclusion principle. What you will do? What you will apply? You will apply inclusion exclusion principle. Yes or no? This inclusion exclusion principle you can apply. In this type of questions, you can apply inclusion exclusion principle. Okay, so it simply means that B is dummy. B should be dummy. I can say B must be dummy. Okay, and A must not be dummy. And A not dummy. So how to find this? Very simple. You find where B is dummy. Okay, so you find where B is dummy. This is what you do. You find where B is dummy and then you remove, okay, from this you remove where A is dummy. From this you remove where A is dummy. Okay, so how many? Where B is dummy, how many? Where B is dummy, total 2 power 2 power 1, total 4 where B is dummy. So B is dummy, that is 4. Now in this you find where A is also dummy. B is also dummy, A is also dummy. Okay, so in this A is dummy, that is 2. Okay, like this. In this A is dummy, that is 2. Okay, so that is 2. So finally your answer will be, I can say that number of functions where B is dummy, number of functions where B is dummy, from this you remove, okay, number of functions where B comma A both are dummy. A comma B both are dummy. So the answer will be 4 minus 2 and that will be 2, like this. Is this clear to everyone? Like this you can do. Okay, so this type of this inclusion exclusion principle you can apply. Very simple point. Okay, this you can apply. For example, if I ask you like this question, I ask you, let's assume that f, there are total 4 variables. Let's assume 4 variables. So what is the number of function? What is the number of function where B is dummy, where B must be dummy? This B must be dummy. A should not be dummy. A is not dummy. Then what will be the answer for this question? Tell me. So you can notice where B is dummy, but A is not dummy. B must be dummy, but A should not be dummy. So how to find this? So there are two ways. You can apply the inclusion exclusion principle. This inclusion exclusion principle you can apply, very simple. Okay, so this inclusion exclusion principle you want. So this and you want. Okay, what you want? You want B must be dummy, A must not be dummy. So from total you can remove, okay, like this is what you want. So something like A intersection B you want. Okay, so something like B is dummy and A is not dummy. This is what you want. Okay, so that will be what? A intersection B. This is what you want. So that will be total. Okay, total minus what should be done? From total what you will remove? Where A is dummy, where B is dummy, or A is no, where B is not, I can say. So any, okay, what you can do basically, just find where B is dummy. Okay, just find where B is dummy. So what is the number of function where B is dummy? Where B is a dummy. What is that? What is the number of function where B is dummy? So that will be 2 power 3. Okay, sorry, 2 power 3. So that will be, I can say, the answer will be 2 power 8. Okay, so that is 256. There are 256 where B is dummy. So okay, here B is dummy. Now, okay, in these, now you find where B is also dummy, A is also dummy. Now you find where B is also dummy and A is also dummy. So this is what you find. Where B is also dummy, A is also dummy. So that will be 2 power 2 power 2. Okay, so that will be 2 power 4, that is 16. Now what you will do? What we want? So the number of function where B is dummy, B must be dummy and A must not be dummy. A is not dummy. Okay, so that will be 256 minus 16, that is 240. Okay, so the answer will be 240. Is this point clear? So you can apply inclusion exclusion principle very easily, you can apply. So tell me, this concept of dummy variable, is this clear? Let me tell you, in the GATE exam, every year they give you some new questions. Every year they will define something new. This is the behavior of GATE exam. Okay, so in the GATE exam, you can this is the behavior you can check. This is the, I can say, this is the GATE behavior. What is the GATE behavior? They will give you something new. They will define something new in the GATE exam. They will define something new. They will define. Okay, like some new concept they will define. And what you will have to do, some new concept will be defined, and what you will have to do, tell me what you will have to do. So this will be defined, and you will have to analyze this. So your task is to analyze this and solve the question. So this will be your task. Okay, so this new concept you analyze and solve. And from the last 2 years, this is okay, analyze and solve. And from the last 2 years, actually they are giving many new concepts, they are giving in the GATE exam. You can check them. Okay, if you check the GATE 2021 2022 papers, if you check, then you can notice one thing, that they are giving many new questions, they are giving. Okay, so that is the reason I am taking these questions where you have to do analysis. Is this clear? Like this dummy variable, see, okay, in the test series also you will find this type of questions. In the Go classes Gate Overflow test series, this type of questions you will find. In the test, if there are, for example, if there are 15 or 20 questions, then there will be 4 or 5 questions where some new concept will be defined. Okay, some new terminology will be defined, the definition will be given to you, and your task is to analyze it. Okay, so remember, this analysis, this is not easy. Like maybe you are not able to do the question in the, like for example, in the test series, in the TOC or digital test of Go classes test series, Gate Overflow test series, some question is there, some new concept is defined. Okay, you are solving that question, maybe you are not able to solve it. Okay, because this is a new concept. Okay, so but remember, if you try like this in every test, if you do this type of questions, 2 3 question in every test, if you do, then by the end of by the end of this year, okay, by the, I can say, by the end of December January, your analytical skills will improve a lot. This is the idea. Okay, that is the reason I am taking this type of analytical questions. Some definition is given to you, your task is to analyze and solve. Okay, so I hope these points are clear. Okay, so you can check in the Gate Overflow Go classes test series, you can attempt the digital logic test, you can attempt. In that test also there are some questions, there are total, I think, 25 questions are there in the Boolean algebra Go classes test series. And from those 25 questions, almost 5 questions are analytical. Some new terminology is given to you, definition is given to you, your task is to analyze it and solve it. Okay, now remember one thing, whether you are in the test, during the test, whether you are able to solve it or not, it does not matter. Okay, because our target is to improve your analytical skills slowly. With every test we will improve your analytical skills. Okay, so once the test is over, you analyze, you see the solution. Okay, you take copy pen and you work it out, and you, okay, you try to analyze that. Okay, you try to solve that question. Once you do that, go to the next test. Okay, like this if you do, okay, then by the end of this year, definitely your analytical skills, your problem solving skills, this will improve very much. Okay, so in the GATE exam, whatever new concept they give you, like we don't know what they will give you, yes or no, they will not give from the notes. So we don't know what they will give you, but whatever they give you, your problem solving skills should be very good, so that you can solve any question. Okay, now let's move on. Let's move on now. Okay, so now the next is K-map tricky questions. What are K-map tricky questions? So these questions I want to discuss. Do you really understand K-map? Okay, so can anyone tell me what is the definition of K-map? If I ask you what is the definition of K-map, then what you will say? What you will say, what is the definition of K-map? Remember, I told you that K-map is just a representation. This is just another representation of truth table. Okay, this K-map, this is just another representation of truth table. So you can notice this is another representation of a truth table. Okay, in which the minterms are put in such a way that it will help in the minimization. Okay, so this is the definition of K-map we already know. Now remember, this is just another representation of a truth table. For example, you know that this is the standard truth table. If I give you, okay, if I give you some truth table like this, you know this is the standard truth table. Okay, and if I give you, for example, 0 1 1 0, now why this is a standard truth table? Because you can notice, okay, these input combinations are in the order of their binary number. They are in the order of their binary number 0 1 2 3. So this truth table is known as standard truth table, that you already know. Okay, this is your standard truth table. Similarly, this is standard k map. Okay, if I give you some k map, then I will say that this is standard k map. Similarly, I can say that if I give you two variable a comma b, then you can notice this is the standard k map 0 1 1 1 1 0. Okay, 0 1. So this order is standard k map, correct? This is a standard k map. So this is standard truth table and this is standard k map. But in the, okay, but remember, if I change this order, then will it be difficult for you? Okay, if I change the order, will it become difficult for you? For example, if I give you some random order, if I give you, okay, then if I give you the function, then tell me, now if I ask you what is function f, then what is the answer? Here what is function f, tell me. Here what is function f? In this, what is function f? In this truth table, this is a standard truth table, this is the truth table of exclusive OR. So here the, okay, the function is a exclusive OR b. This is your function. Now tell me what is the function in this truth table. This is not a standard truth table, you can clearly check. This is not a standard truth table. The binary value of this is 2, binary value is 3, binary value is 0, binary value is 1. Okay, so this is not the standard truth table. Now, so what is the function f? This is not a standard truth table, but my question is what is function f? So you can convert this. Remember, this is not a standard truth table, but you can convert into standard truth table if you want, or you can directly find the answer. Or what you can do, you can convert, okay, just convert this into standard truth table. So for 0 0 value is 1, for 1 1 value is 1, and for the remaining value is 0. So you can notice f is equal to a, okay, XNOR b, a XNOR b. So this is how you can do. Or you can simply see here that, okay, so here you can simply see, you can directly say that for 1 1 value is 1, for 0 0 value is 1, so it is exclusive NOR. So this is what I'm saying. So remember, this is the standard truth table, but this is not a standard truth table. So you can convert into standard truth table. Okay, then you can find the answer. Then answer will be a exclusive NOR b, a XNOR b. Or you can directly find. Okay, similarly what I'm saying that this is a standard k map, but if I give you some other k map, like for example, if I give you this k map, then how will you find the function? Some other k map I give you, not the standard. I will not give you the standard k map. Let me give you some other k map. For example, like this 0 0, okay, 1 1 1 1, okay, 0 1 1 0. Okay, let me give you this standard k, sorry, this k map. Consider this k map for f, a comma b comma c. Okay, some this k map I am giving to you, and let's assume this k map I am filling this k map like this. Okay, 0 1 1, okay, 0 1 0 1 0. So tell me what is the minimized expression of f? Find minimized expression of f. Find minimized expression of f. This is my question. So how will you do this? I am asking, find the minimized expression of f. Tell me, will you do this? Tell me, will you do this? Will you do this? Is this correct? Are you going to do this? Are you going to do this? No, this is wrong. Okay, if you do like this is wrong. If you do like this, okay, then definitely this is wrong, because this is not a standard k map. Okay, the reason, what is the reason? The reason is not a standard k map. This is the given k map. Given k map is not a standard k map. Is not a standard k map. Not a standard k map. So this is what I'm saying. So what you will do? Okay, to solve this question, what you will do? Very simple. First you convert into a standard k map. Okay, this is what you do. Let's convert this k map, let's convert into standard k map. Okay, first of all what this is telling you, actually what this is telling you, what information this is giving to you? This information it is giving to you. Tell me what are the min terms of f. Tell me what are the min terms of f. What information this is giving to you? This so for example, tell me for 0 0 0, For 0 0 for 0 0 0, what is function value? What is function value for 0 0 0? For function, okay, that is 0, because you can notice, okay, 0 0. For this 0 0 0, function value is 0. Tell me for 0 0 1, for 0 0 1, a b c, for 0 0 1, what is the function value? 0 0 1, so function value is 1. Okay, what is the function value for 1 1 0? For 1 1 0, so the function value is for 7, for 6, function value for 6, 1 1 0, 1 1 0, that will be 1. Okay, so that is 1. What is the function value for 1 0 1? What is that? 1 0 1, the function value is 1. So like this, I hope this is clear. Now what we will do, so this is the idea. Now let's convert this into standard